let's do the consensus for the Ohm's Law lab. And I think it went really, really well, actually. That's the first time I've done this lab, so I was pretty happy with the results you got. And see, whose notebook is this? Okay, so we've got very nice, nice looking data here. And what we did as a class is for these voltages, we measured the currents that was flowing through a 10 ohm resistor, and then a 51 ohm resistor, and a 68 ohm resistor. Okay, and these are the data that we actually, that was measured, okay, by a particular group. And I think one of the things that you saw using those data was that if we graphed them, and I had you graph it like this. I had you graph the voltage as a function of the current. Now this is a little bit weird because actually the way we did it, the voltage was the independent variable, and we actually measured the current based on the voltage. But there's no law that says you have to put the independent variable on the horizontal axis. You can do whatever you need to do. And so we graphed these, and what you found was that when you graph the data, it was a straight line, right? And then we said, well, when you want to write an equation for a straight line, it's very easy to do, right? A straight line equation that you learned all about in your math classes. Y equals mx plus b. The most basic equation in Algebra 1. This is the y-axis, vertical axis. This is your slope, this is your horizontal axis, and this is your y-intercept. And what we found was that, we had E equals, and then we measured the slope, which was the change in voltage over the change in current. Right? We made a little slope triangle, a rise over run. This is how much I changed my current, and it resulted in a certain change in voltage. So you had to make a slope calculation. And then the horizontal axis was, well, instead of calling it the x-axis, let's call it the current axis. That's fine. And there's I. And, well, let's take a look at the data here. If I were to treat the whole thing as a, here it is. Let's take a look at the 10 ohm resistor data. So if we start from 0 and go out to here, look at this. I could go 5 divided by 0.53. So 5 divided by 0.53 equals, and I get 9.43. I could even do this. I can go 3 divided by 0.317, 3 divided by 0.317, and you get, wait a minute, 3 divided by 0.317, and you get about 0.9 or 9.5, which is pretty darn close to 10 ohms. Now remember that these resistors have a certain tolerance, plus or minus 5%. So 5% taken off of the 10 ohms, it's about 9.5 ohms. So that's in the slope of this line is within the range of the resistor. Now when I take a look at this, 5 divided by 0.099, look at that, that's great. 5 volts divided by the current, 0.099, I get 50.5. 50.5 volts per amp. That's 50.5 is pretty darn close to 51. You take the voltage, divide it by the current, and you will get that resistance. These data are really good. You guys did a good job recording data. Now what about these? Does it work for these? Well, what is 5 divided by 0.077? Well, let's figure it out. 5 divided by 0.077 equals, rounds off to 65 ohms. It's pretty darn close to 68 ohms. Okay, what's 5%? It's about, a little over 3. Okay, take 3 away from that and you're within the range here. So these are very good. You guys did a really good job recording your data. And so what we did was we measured voltage and current for a given resistor, and what comes out is Ohm's law. You see, this right here, the slope of this line, the slope of voltage, when you graph voltage as a function of current, you're going to get a straight line, and that straight line is going to have a slope to it. The slope is resistance. So you can say the change in voltage over the change in current is equal to R. That's resistance. So if I plug that in place there, I can say voltage is equal to resistance times current. Or I can rewrite it. Resistance equals, usually they go IR, E equals IR. This is how Ohm's law is usually written down. But we proved it. We proved that this is true. 3 times for 3 different resistors. You all did this. So this is pretty cool. Okay, we did an experiment where we showed that Ohm's law is true. In fact, we can even think of it as deriving Ohm's law. And remember that resistance here, it's the rate at which you change voltage as you change the current. And that's going to be in volts per amp. And a volt per amp is, what do we call a volt per amp? It's an ohm. That's how we measure resistance. And instead of an O, we make a little horseshoe shape omega thing like that. Okay, so this is Ohm's law. Let's make a little quantity chart. And then we can, and an equation list, and then we're going to solve some problems. We have the quantity. We have voltage, current, and resistance. Oh, you know what? That's the, hold on. I meant to write the words. Voltage, current, resistance. What's the variable? Oh, thanks. I'm sorry. I'll give you extra credit. All right. What's the variable? The variable is E, I, and R. What are the units? And how are those units abbreviated? This is volts, and we abbreviate with a V. This is amps, which we abbreviate with an A. And this is ohms, which we abbreviate with an omega. Okay? And the equation is this, E equals IR. Now remember, you can always, you can make a little, one of those little triangle things that help you remember. Okay? Have you seen these before? They do sometimes do them with density and other equations. What if I want to find resistance? resistance equals voltage divided by current. Or you can just use algebra, solve this for resistance. Divide both sides by current, you get resistance equals E over I. What if I want to know what the current is? Cover up the current, and it's E over R. Divide both sides by resistance. It's the voltage divided by the resistance is equal to the current. What if I want to know the voltage? Cover up the voltage, and it's I times R. Current times resistance gives me voltage. Okay, so now what I'm going to do is give you some problems to work, and I'm going to have you do them on whiteboards, and I'll give you about 20 minutes to work them all, and then we're going to take a quiz. The last 20 minutes of class will be a quiz. But anyway, this is Ohm's law. That is all.